Okay, let's make the video on slit-lamp biomicroscopy. Today's is first part video, first part of the slit-lamp biomicroscopy. We are not going to talk about the illumination technique in this video, but we are definitely going to talk about a lot about illumination system, observation system, what is magnification, and some mechanical system. And we're definitely going to talk about optics, the basics optics, and the basics of slit-lamp. Okay, it's very important as a student because basically you have to have a good knowledge of how it functions, and then you later on you learn about the illumination techniques. So illumination techniques are not that difficult. You have to understand things and then you have to practice illumination techniques, but when you try to understand the machine itself, it's quite difficult. Okay, so let's move and slowly. So today's video, it will be long, it will be 25 or I think. Let's move. So introduction. Slit lamp is an instrument designed specifically to examine eye and adnexa. That's okay. And the operational component consists of binocular microscope and the light source. Basically, light source means illumination source, and the microscope means observation system. This means illumination system. Light source means, so provide the light in the form of slit to observe the various ocular structures. It's very important. It not just provide light, it provide light in the form of slit, because the magic is there whenever there is a slit. Okay. Without a slit, it's not a magical. So just understand why. I will explain in a functional optics basically what is the functional principle, then I'll definitely explain why slit is magical. But try to understand it. Slit lamp basically means these three terms. Slit is very important, then lamp, then bio, and then microscopy, isn't it? Biological things, basically eye, where slit is very important. Okay, let's move forward. It provides the stereoscopic, definitely. It's 3D vision is very important. These structures. Okay, move forward. So just let's talk about the history a little bit. Not this is the only slide that I am talking about history. So year 1990 and 1911. So basically, Alvar Galston presented the first slit lamp, and basically before that slit concept is there, but slit basically it only light projected anterior eye and observed the examination with a monocular binocular loops. So basically Goldstein is there. I think you know the name of Goldstein because he won the Nobel Prize. I think he's the only person from ophthalmology who get Nobel Prize, not because of the slit lamp. Just to understand it, it's not because of slit lamp, but because of schematic eye. Goldstein schematic eye. So Carl Zeiss company, what they did, they produced a commercial system based on the Goldstein concept. So first commercial slit lamp is made by Carl Zeiss, and then this name I think you know, Cope, isn't it? Leonard Cope, and proposed the combination of Goldstein slit lamp projected with a Zeiss binocular corneal microscope into one unit. So earliest integration of light projection and a microscope. So done by Cope. And while this name Wilhelm in 1993 improves the handleness and compactness, so he basically do all the things. The basically unifocal common axis rotation is done by him. And then Hans Littmann, what it is? It enhanced the converse design of Zeiss slit lamp. So basically, it enhanced. And then Hans Coleman proposed the similar design with a common rotatory axis. The concept is used by later on Hackstead, because Hackstead is very famous name in slit lamp, and definitely Zeiss is also a famous name. In 1958, 1969, what Carl Zeiss did, that introduced slit lamp series of 900. So basically, vertical upward positioning of the tiltable slit light projection. I think you will know when you see actually Hackstead slit lamp, but right now it's completely okay. So added 3D joystick to the instrument base. That's very very important thing, isn't it? 3D joystick is very important. So simplified the adjustment of all three: spatial, direction, and design of principle. Basically, we people, we current generation people, we think that it's very easy thing that we have 3D joysticks, but it, yes, definitely all credit goes to Hackstrick that they developed that joystick, which is very important, and because of that joystick our life is easy, isn't it? So optical principle, what is the optical principle? We will definitely going to talk about a deeper in optical principle. Just optical principle, what do you mean by optical principle? So basically two things is there. One is illumination system, another is observation system. Observation system means microscope, illumination system means light throwing to the eye, basically slit throwing to the eye. Okay, mounted on the movable trolley based on the common center of vertical axis. I'll tell you what is common center of vertical axis. Foci on the same plane, isn't it? What do you mean by foci on the same plane? Illumination system and the observation system both has focus on the same plane. That's what it means. So focus on the same plane means illumination system, the where light is thrown exactly at that particular place, microscope is focused. That's what it means. That is foci on the same plane. And these two coupled around the same center of rotation. What these two? These two means illumination system and observation system are coupled around the same center of rotation to ensure the par focus means pair of focus of microscope and the slit beam. That's very important. Just understand. Some optometrists or some optometrist college in Viva, they used to ask what is the principle of slit-lamp. I just hate that particular question. So see, people are talking about, yes, it's some people talk about it's basically principle of slit-lamp is microscope, and some people talking principle of slit-lamp is coplanar, coaxial, copivotal. I don't know what we mean by that. It's completely okay because I don't think it's principle. Basically, I don't care it's principle or not because you have to understand things. Why? Because both microscope and slit lamp focus in the same focus, make a pair of focus, but we have to break it whenever we are trying to do another things. And how we will going to break it is definitely you will know in your clinical posting, but I'm going to talk about it. So basically, sometimes people, many teachers ask you the question that what is the principle of split time, just throw this answer to them. Okay, it's a coaxial and co-pivotal is a principle, basically means illumination system and observation system focused at the same uh, particular place, and obviously we can break it, especially in high state it's very easy. So then onwards, work on the principle of compound microscope. And sometimes even faculties or students tell what is the principle of slit lamp. They call it same as a principle of compound microscope. Yes, there is a microscope. Same principle of compound microscope. So it doesn't matter this number. Okay, eye objective piece and eyepiece. Basically, there is more complex than what you think. Adjustable illumination system, which is very important. A narrow slit beam, see this important point. A narrow slit beam is very bright light produced by the lamp. Why narrow slit? It's important. Okay, I'll tell you later. This beam is focused on the eye, which is then viewed under the magnification of microscope. Basically, narrow slit is thrown to the eye, and exactly same place is viewed by the microscope. Okay, so basically this the illumination system, which is this, is fixed on the same place where observation system, which is this, fixed on the same, and they have common this axis, isn't it? It has common axis, this vertical axis, the shared swivel axis for stereo microscope and slit illumination. So basically illumination system and observation system have same point and same axis for the rotation. Okay, I've taken this picture from this book, the slit lamp. Okay, so moving forward, now this is the functional principle which I want you to understand. Okay, functional principle, just I want you to understand very well. The cornea and the lens are held, the healthy eye are highly transparent, isn't it? We want cornea and lens to be transparent, isn't it? So they are very transparent in healthy eye because they consist of ordered tissue structure without strongly absorbing chromophores, which makes them difficult to visualize, isn't it? If you throw the light and if you see patient's eye, do you see the cornea or do you see the iris, the color of the eye? Isn't it? You see the iris because cornea is transparent. It's very difficult to see the cornea. I'll I'll show you another picture there. So isn't it? It's very simple. So observing, there is no observing chromophore, and that making very difficult to visualize the corneal lens with a normal transmitted or reflected light. In such a case, the light amplitude changes are too weak, and the phase changes cannot be detected by human eye. Basically means you cannot detect if there is cornea or not. Cornea is basically transparent, isn't it? However, the transparent structure can be clearly observed in scattered light. My goodness, that's the point. Can be observed in scattered light How to get that scattered light? By projecting a bright, narrow slit of illumination against the dark background. This is gold. Just remember, this is gold stuff. Many of the optometry students, they have never understood this concept. Why we need slit? Because in slit lamp, whenever you make slit, that bright narrow slit illumination against dark background, then if you throw the slit to the cornea, then the the light coming back to your eyes as an examiner is a scatter light because of the narrow brighter light you throw against the dark background, and then you see the cornea layer by layer. So that's, otherwise you cannot fit scleral lens, you cannot comprehend the world, you cannot comprehend how deep the foreign body in cornea, you cannot comprehend in which layer of the lens cataract is. It's very difficult otherwise. Okay, that is scattering light is fundamental principle. Okay, this is very gold stuff. This, just try to go back, understand it, just try to understand this concept. Okay, so functional principle, this situation is similar to the beam of sunlight enter into a dark room through the small slit, where dust particles become visible within the beam, isn't it? If the light is thrown not in the small aperture, then it's difficult. In slit lamp, narrow beam is shaped by the two knife edges, passes through the entire eye, and is scattered by the microscope in homogeneity, producing slit shape scattering image that called optical section. So that's why we throw optical section to see the section of the cornea. The brightness of the optical section increases with a higher slit illumination and the greater portion of the blue light from the illumination source. So basically means, see in this picture, can you see there is a cornea except this reflection, isn't it? This is Purkinje reflection. But can you see here cornea in in this? Definitely you see cornea. This is cornea, isn't it? This is lens, isn't it? So how you see this? Because of the scattering, backward scattering basically. So front view of the eye with a slit in which the scattering image provide the optical section in this picture I am talking about. And with such an illumination technique, we can see cross section of the cornea and the lens. So can't you see the cornea and the lens, cross section of the cornea and the lens? Just see, this is lens cross section, isn't it? And see, this is cornea cross section. Can you see it? So it's very important to throw the slit. Okay, so based on the illumination system, there are two types. One is Zeiss, another is Hagstead type. Basically means in Zeiss, light source in the bottom, at the bottom. In Hagstead, light source at the top. And that's it. Don't be panic. So basically, light source is here in Hagstead with the top. In Zeiss, light source is here in the bottom. So that's it. So basically means light source in the top, isn't it? Yeah. So basically means light source is here in the bottom, isn't it? So okay, let it be. So parts of the slit lamp. So mechanical part, let me talk about mechanical part first. It's just forehead rest, chin rest, fixation target, power supplied unit, locked control, joystick. I think you will see in your posting. Observation system, which is basically microscope, eyepiece, observation tube, magnification changer, and camera or video adapter. And nowadays, so what is mechanical part? So we don't have to talk about a lot of things, but let me just put it here. Instrument base, you need a base that provide foundation. Cross slide table, you need a table. Vertical movement column, so basically there is a movement in vertical up and down, isn't it? Joystick, which is very helpful, 3 coordination. Rotation action pivotal basically means common axis is there, isn't it, for illumination system as well as observation system. So both slit lamp projector and microscope, basically slit lamp projector means illumination system, microscope means observation system, and the common axis rotation will eventually help there is an angle between two systems, isn't it? So slit light projector arm, and that's an illumination system. Microscope arm, that's an observation system. Magnification change is very important nowadays. Magnification change, yes, sometimes it's just like slit, sometimes it's like drum system. So headrest and chin rest, yes, there is important. Base plate, yes, and locking system, yes, it's very important. Just if you want to know about it, just pause the video and see what is there. So This is the picture where when I'm talking about this rotation axis. I have already talked about this same place that illumination system and observation system is locked, and we can see same place both things are locked, and there is we can make an angle between them, isn't it? So Hackstead model same. So illumination system, I don't talk about this how much the lamp locks is, but basically yes. Consider lens system. Two plan next is I'll talk about it. Slit lamp on other diaphragm. This is sternopic slit we need definitely because to send the slit. There is a filters definitely neutral density filter, cobalt blue filter, red free filter. We're going to talk about it. Projection lens, small diameter. We'll talk about it. Reflecting mirror. Yes, we'll talk about it. What is illumination system? Basically means see there is a one bulb, and that bulb passes through the condensing lens. Basically bulb send the diverged light, and we need condensing lens, and from the condensing lens there is a variable width slit because slit controls the width of the slit and height of the slit basically, and it passes through the filters because filters it's very important for clinical cases. We have to see a lot of different cases and a lot of different filters, definitely useful. And that then light passes through the projection lens and it passes to mirror, and the mirror reflect to the patient's eye. Okay, that's a rough idea. So in this particular case we have to know what Kohlner's illumination principle, because Kohlner's illumination principle is so useful. That's why we have something slit, and that sharp slit which is very useful. Just remember this picture, I'll show you this picture again and again. So this is what I'm going to talk about the why homogeneous slit image is thrown onto the patient, and what is the principle basically corners type illumination means, and why it is so important to us. Okay, let me explain. First, light is thrown from the bulb, and there is a collector lens. Okay, the collector lens that collects the light, which is basically thrown in a multi-direction. The light source grown filament is imaged by the collector lens into the objective of lens. Basically means the image of the light source basically thrown into the objective lens. This is what I'm going to talk about. So basic principle is the collector lens, see this filament color red, see the lens, and exactly the center that filament is there, that's actually image of the filament, image of this making here by this lens. Okay, so objective lens image at the field stop mechanical slit in front of the collector lens into the screen as a consequences of homogeneous. So basically this collector lens makes the image of this filament at exactly at the objective lens. That's why we can throw the homogeneous slit imaging particularly at a focal length what where we want to send in in case of exactly illumination system. So that's why homogeneous slit image is formed at particular place where we want. It's very basically it's a magical thing that corner derived this illumination type of illumination. Okay, it's very important why it does that. So basically that's the concept here, and so this is how a one only one eye views, isn't it? See, there's a large objective lens, and there's a magnification factors, basically drum magnification, prisms which rotates the image, and again eyepiece, isn't it? It's basically what it is. And I've taken this picture from this book. It's great stuff. Okay, so this is the view binocularly. Why? Because slit lamp is a binocular thing, isn't it? So large objective lens, there is a magnification factors here, prism which actually rotate the image, and then eyepiece. So slit lamp magnification is not simple thing. It's like nothing like objective lens and eyepiece. There is a magnification. No, it's complex. Like there is three different type of magnification, and then slit lamp happens. But this is a rough gross overview of slit lamp binocularly, which is very important. And I have taken this picture from this book, Applications of Biomicroscopy, the Slit Lamp. It's a very good book. So the slit within the illumination system must have sharply demarcated edge and adjustment. That's what we are talking about in colonel principle, why that sharpness came there. Slit width and height must be adjusted such that any shape patch from the slit to circle shape projected and increase illumination. Why? Because we want that, because we have to measure a lot of lesions like corneal lesions, and we have to adjust slit width too, isn't it? And the graduated slit width size lesion, obviously ability to rotate the lamp housing if protector scale is included. Basically, yes, we definitely can. If there is slit like this and we can rotate that bulb house together and make 90 degrees, isn't it? It's very simple. Must have the facility to displaced and offside decoupled. Basically means principle of slit, so-called principle of slit lamp is coupling, and we can decouple it. Basically means what? Illumination and observation system are not focusing at the same point. Principle of coaxiality is breaked. Basically means decoupling means this. See, this is done. This is width controlling. No, we know it. This is how we know. So but this is a very important point in hexprit. So it does what? It does decouple the illumination system with the observation system, and we use in sclerotic scatter, sometimes in retro illumination techniques, yes. But it's this knob is very helpful to decouple the slit lamp. This is the term basically means. So what are the filters that are very important? It's crucial that red free filter. When you are trying to look blood or blood vessels, isn't it? Red free means blood or blood vessels free. So basically red free is used sometimes in rose Bengal staining definitely, but otherwise neovascularization in the cornea or elsewhere, in definitely in retina to enhance the contrast of blood. Neutral lens filter to reduce the brightness and increase the comfort. Definitely, you don't want to throw the light in interview where it is so hard and corneal injury is so hard. It's very difficult, isn't it? So polarizing filters reduce the unwanted specular reflection and enhance the visibility of suitable defect. Okay, that's good. Cobalt blue is central important whenever you use fluorescent staining. As an optometrist, it's a gold thing, isn't it? For contact lens practice, for me, it's very important that fluorescent cobalt blue. For me, whenever I show my student rings, it's very important. So sometimes Kodak what in 19, yeah, I haven't used that particularly that filter, but it's, I think it's outside of the system. I don't see this Kodak Wharton number 12 in particular slit lamp. Maybe I haven't used, but I don't know. I don't know about it. Okay. So graticules. What is the graticules? Graticles is very helpful as an optometrist and especially in contact lens practitioner. Whenever you fit contact lens, whenever you want to know the rotation, graticles the best. So I think you have to see whenever is there a chance of making graticles and see things from this. As a contact lens practitioner, it's very, 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 very helpful. So now come to objective system. Now come to telescope and the magnifications. Okay, so microscope basically and the magnification. So objective system, the resolution of image is governed by microscope dependent. So what are the things that are dependent upon the microscope? One, objective diameter of the object lens. So it basically means how much light it incorporates to the system. Working distance, definitely refractive index of the medium between objective and the lens and eye. Wavelength of the light. Let's discuss further. Biomicroscopy, objective to plano-convex lens and eyepieces, but just not stick to that numbers. Okay, tube converges 10 to 15 degree for a good hysteresis. Yes. A pair of prism or to reinvert the image. Yes. And range of range that accommodates magnifications 6 to 40 times. But I want to tell you, I have seen a lot of telescope, slit lamps in these three magnification: 10x, 25x, and 16x. You'll see commonly in drum system, in flip system, it's 10x and 16x. I have seen common this magnification. Okay. Fine. So basically low magnification 70 to 10 times, medium magnification 20 to 25 times magnification, high magnification 30 to 40 times. So there are two type of uh, magnification changing system. One is Greenough type, another is Galilean changer type. Okay, but we definitely, when you are talk in like colloquially, when we talk with the people, normally we talk it as a flip lever change magnification. That's called flip type. Okay, so we don't use clinically the Greenough type. Okay, then basically we have to give credit to Greenough. So but yes, we generally take flip type. So basically means these are two type of magnification, 10x and 16x. Okay, this is, we normally call it a drum magnification, drum type of magnification, which is basically Galilean magnifier. So basically it has normally 3 or 5. Basically I have seen 3 a lot of in my clinical practice, which is 10x, 16x and 25x. So this is the system where example of magnification changer of 5 power option in Galilean and drum magnification. So basically means this is how it rotates within the system when we rotate that drum, and I have taken this picture from this book. Okay, so another way to change the magnification can be changed by directly changing eyepiece of the slit lamp. So you change from 10x to 16x eyepiece, finished. This is also another way. Okay, just remember this is also another way. Now here we come, which is very important concepts I think for you guys. Total magnification of slit lamp depend upon three things. One is magnification by objective lens. Another is magnification by the telescope that is within that system, that drum we're changing, isn't it? Third is magnification by the magnification changer. Sorry, magnification by telescope means eyepiece, and magnification by magnification changer means that drum which is changing, that flip which you are doing. Okay, these three things, and I have taken this example. If the objective lens has a magnification 1.6 times and eyepiece has a magnification of 10 times, and the magnification of changer sets in 1.5 times, then what is the magnification? Just 24, isn't it? So this is how we calculate the magnification, total magnification of the eye. Okay, so let me go to the, I think this is last slide, this is reference. Let me go to one picture and then I'll explain, and this I'll finish all these things. Okay, so let me talk about it. Just try to understand this concept. This is illumination system. Light is thrown here and it's collect here. This is slit, and then whenever this slit is thrown, the filter is here, and then this objective lens, it passes the light and it's shown illumination. Then from there, when light reaches to eye and return to it, this prism is not completely blocked, then light comes here and into our eyes. There is also illumination, there is observation system, which is basically slit lamp, basically microscope. So same thing is here too, isn't it? Light came, this is collector channel, condensing channel, this is slit aperture, and filters, it passes through this lens, and from here patient's eye. From the patient's eye, this mirror is not complete opaque mirror, so light from there passes to observation system. And definitely in observation system we have many things. Basically we have most important is microscope and the magnification, how it goes. Okay, this is the concept that I wanted to talk with you, and um, this is the lovely concept that I want you to understand. Okay, so these are the reference, and one of the things that I want to talk about today is, yes, definitely video is too long, but remember, whenever I show you the reference, just try to understand what are the reference. Because of this reference I'm making the video, because of this reference I have got the knowledge. So I want you to know direct resources that you can go and buy these books and try to understand uh, whatever I have understood till now. So it's very helpful that you go pause the video and you search this book, you want to try to understand this book, and if your friends have this book, borrow that book and try to understand deeper and deeper about the slit lamp. And these are great references. This is first I have references because I have used this model, first model of the icon. Basically pictures are very good, and the 2020 model I'm not allowed to use, so This is the first model I have used. So it's a very great book. These three books are golden books. Just try to understand clinical procedure, optometry, this primary care of optometry, this Smith by Slit-Lamp, what SS basic Slit-Lamp microscope. These all books are good. Okay. So I think it's too much. It's 30 minutes. So Bistan choose.